All right, so solving multi-step unit conversion problems, each step, so they use these solution maps in your textbook, and I don't think they would be very helpful for me, but they might be helpful for you, and you can access your textbook through Mastering Chemistry through eCampus if you want to do that. But if I have 194 centimeters and I want to know how many feet that is, I have to find a connection between centimeters and feet. And there isn't one directly. I mean, you can probably find one or make one, but on your unit conversion sheet, there isn't one. So you would use multi-steps to do that. So if I write down what's given to me, that 194 centimeters, then the first conversion factor I would have to use, because I want to go to customary units, right? I want feet. Customary units are the units that we use here in the States. So I would start by looking here at this, and I would use the first thing here, the 2.54 centimeters in an inch, which is what they have right here. And the centimeters part would have to be on the bottom so that it cancels out with the centimeters up here that was given. So I'm going to put 2.54 centimeters is 1 inch. Now, the units that I have, because the units canceled out, the numbers are all still there, but the units canceled out. The unit that I have would be inches if I was to stop right now. But I don't want inches, I want feet, so I have to keep going. So then the next conversion factor I would use would be 12 inches in 1 foot. And so now feet would cancel out, numbers are still there. I mean, inches would cancel out, the numbers are still there, and I'm left with feet, right? So now when I do my calculations, I would type in 194 divided by 2.54 divided by 12. Because if you were looking at this purely from a mathematical perspective, it would be 194 times 1 divided by 2.54 times 1 divided by 12. But multiplying by 1 doesn't really change your answer, so I usually don't include it. So we just divide by both of these, and that's how you do the math. So if I put that into my calculator, I get 6.36 rounded to sig figs. So the sig fig part, we just look at what's given because these are conversions, so they have an infinite number of sig figs, so they're not affecting the answer. And so you round your answer to the least number of significant figures. And the number of significant figures here is 3. So my answer should have 3 sig figs. So it'd be 6.36 feet. All right, so here is some examples. The first one says a recipe for making creamy pasta sauce calls for 0.75 liters of cream. Your measuring cup only measures in cups. How many cups of cream should you use? So we're going to say we have 0.75 liters, and we want to go to cups. So looking at the chart that you have, right? I have 1 liter is 0.264 gallons. And that's it. That's the only place where I have liters. So that's what I'm going to use. So I'm going to put 1 liter on the bottom to cancel out liters, and I'm going to put 0.264 gallons. Well, I want cups, so I need to get to cups. So right now I have gallons. And on your sheet, you have the 1 liter is 0.264 gallons, and I don't want to use that again because I don't want to go back to liters. So in the other place where I have gallons, I have 1 gallon is 4 quarts. So I'm going to put that on here next. And I'm going to put the gallon part on the bottom because I have gallon on the top here and I want it to cancel out. So I have 1 gallon is 4 quarts. All right, so looking back at my sheet, because now I have quarts, but I want cups, right? Looking back at my sheet, I have 1 quart is 2 pints. Now, I don't want pints, I want cups. And I don't know if you watched the video before, but I had told you that there was one volume unit that I forgot to include that was in some of the calculations, and that is that there in 1 pint, there's 2 cups. So 1 pint is 2 cups. So now if I look at all my units, the pint cancels out, the quart cancels out, the gallon cancels out, and liter cancels out, and I'm left with cups. So whatever number I get from my calculations, it's cups. And it's the number of cups in 0.75 liters. So my calculations are going to be 0.75 times 0.264 times 4 times 2 times 2. And so my answer is 3.168. This is 2 sig figs in it. And so rounding my answer to 2 sig figs, it would be 3.2 cups. All right, the next one, a recipe calls for 1.2 cups of oil. How many liters of oil is this? So I'm going to write down 1.2 cups, and I want to go to liters. So the only place I have cups is right here. 2 cups would go on the bottom to cancel out with cups on the top. And that is equal to 1 pint. Remember, the top and the bottom has to be equal to each other so that you're not changing the amount that you have. You're only changing the number because the unit is changing with it. All right, so now I have pints. I already used this one, so I don't want to use it again because that would just get me back to cups. So now I'm going to use this one. 2 pints is a quart. Pint will go on bottom because I have pint in the top here. Now I'm going to go to gallon. So it's going to be 4 quarts in 1 gallon. And then I'm going to go to liters. So this is exactly the opposite of what we did before. So now gallon cancels out, quarts cancel out, pints cancel out, and cups cancel out. So it's 1.2 divided by 2, divided by 2, divided by 4, divided by 0.264. Because you're multiplying by 1, dividing by 2, and then you're multiplying by 1, and then dividing by 2, and you're multiplying by 1, and dividing by 4. So every single time you have a number in the bottom, you divide by that number, and every single time you have a number in the top, you multiply by that number. The only time I don't do that is when the numbers are 1. So it's 1.2 divided by 2, divided by 2, divided by 4, divided by 0.264. And so this is going to be 0.284 liters, or 0.28 liters, rounded to 2 sig figs because this has 2 sig figs. All right, an island is 5.72 nautical miles from the coast. How far away is the island in meters? So I don't think nautical miles is the same as miles, but we're just going to say that it is. So I'm just going to say I have 5.72 miles. And then we want to go to meters. So there's 2 different ways you can do this. I'm just going to use the simplest way. All right. So I want to get to meters. Meters is a base unit in the metric system. Miles are customary units for the US. So I am going to go from miles to kilometers because a kilometer is in the metric system. So on your thing, it's the last one under length. We have 1.609 kilometers is 1 mile. So the 1 mile will go on the bottom, and then 1.609 kilometers will go in the top. And then if you look at your metric system conversion, so the big table that starts with tera and then giga, then mega, then kilo, if I look under kilo, it says that 1 times 10 to the 3rd meters is 1 kilometer. Remember, the number that's on your table goes with the base unit, and the prefixed unit is always 1. So I have 1 kilometer is 1 times 10 to the third meters. So kilometers cancels out, miles cancels out, and I'm left with meters. And so if I put this in my calculator, I have 5.72 times 1.609 times 1 times 10 to the third. So that's going to be, I'm going to get 9203.48 meters. Now, you have to watch out for how you enter these into your calculator. This number, the 1 times 10 to the third, should be entered in, and it should look like 1E3. I know there's other buttons on your calculator, and it will work about half the time, but that button was not used to be used for scientific notation. Okay? So you're going to type this in, and you're going to type in 1 second, comma, and this is right above the number 7 on your calculator, 3. And that stands for 1 times 10 to the third. You don't put a times in, you don't put a 10 in, you don't put a caret, the little exponent thing in. You don't put any of that in because you're using this E, and that stands for exponential notation. So then if I look back at my sig figs, I have 5.72, that's 3 sig figs, so I'm going to write this in scientific notation, 9.20 times 10 to the third meters. Okay, so I wanted to try to do something a little bit different here and do some off the top of my head. So let's say that I have 4.3 times 10 to the 15 nanoseconds. And I want to know how many kiloseconds that is. So I'm going to write down what's given. So here's nano. Okay. So what this means is that 1 nanosecond is 1 times 10 to the negative 9 seconds. Remember, this number that's here on your chart goes with the base unit, the unit without the prefix. So in my conversions, I'm going to say, okay, 1 nanosecond, and that has to go on the bottom because I have nanosecond in the top, is 1 times 10 to the negative 9 seconds. Now, I don't want seconds, I want kiloseconds. So the next conversion I'm going to use is seconds to kiloseconds. So 1 times 10 to the third seconds, so 1 kilosecond, is equal to 1 times 10 to the third seconds. Again, the number given goes with the base unit. So I have 1 times 10 to the third seconds is 1 kilosecond. So this is going to be 4.3 E 15. Remember this E, you get that by pressing second, comma, times 1 E negative 9, not minus 9, but negative button 9, divided by 1 E 3. So I really encourage you to get your calculator out and try to do a few of these so you know you're doing it right with me, because it'll help you remember how to do it. Okay, so then you should get 4,300 kiloseconds. All right, so then next, let's try 9.8 times 10 to the negative 12 megagrams is equal to unknown number of micrograms. Okay, so I'm going to write down what's given. And both of these have grams in it. So I know that it's a metric because I've got prefixes and they both have the same unit. I'm going to get rid of this stuff. There we go. So mega is up here. And so that's going to be 1 megagram is equal to 1 times 10 to the 6 grams. And so the megagram part goes on the bottom. And then I want to do micro. So micro is 1 microgram is equal to 1 times 10 to the negative 6 grams. So when you put this in your calculator, it's going to look like 9.8 e negative 12 times 1e6 divided by 1e negative 6. And that should get you just 9.8 micrograms. All right, unit conversions in both the numerator and the denominator. So these can be a little bit confusing for some students, simply because we've got a fraction starting out. So I have 48 miles per gallon. So that means I have 48 miles over 1 gallon, right? So for every 1 gallon, I could drive 48 miles. So I want that in kilometers per liter. So the first thing I'm going to do is convert the miles part to the kilometers part. And it really doesn't matter. You can start with the numerator or the denominator. It doesn't matter which one. But I'm going to start with the miles. So the unit conversion I'm going to use there, because we're dealing with miles, is customary. Is 1 mile is 1.609 kilometers, and that's off your chart. So I'm going to put the 1 mile on the bottom and put 1.609 kilometers in the top. Now I want to go from gallons to liters, because if I look at miles, miles is canceled out, so I have kilometers. So right now if I was to stop, I would have kilometers per gallon. But I don't want that. I want kilometers per liter. So I have gallon down here, and the conversion between gallon and liter is 1 liter is equal to 0.264 gallons. So I'm going to put 0.264 gallons in the top because I have gallons in the bottom and I don't want gallons. I want liters down there, right? I want kilometers per liter. So 0.264 gallons is 1 liter, so gallons will cancel out. And the units that I'm left with then are kilometers per liter, because gallons is gone and miles is gone, and what I have left is kilometers and liters. So my answer is going to be 48 times 1.609 times 0.264. And so that's going to be 20.389248. So to 3 sig figs, that would be 20.4 kilometers per liter. All right, the next one says a prescription medication requires 11.5 milligrams per kilogram of body weight. So we have 11.5 milligrams per means to divide in math. So that's per kilogram of body weight. So that's the weight of the patient. And then it says, convert this quantity to the number of grams required per pound of body weight and determine the correct dose in grams for a 145-pound patient. So I have a 145-pound patient. Okay, And then I have this. So when you're given two numbers, I used to get really confused when I was first learning chemistry of which one to start with. And then it dawned on me what I had been doing wrong. So when you're doing this, you always start with the number that does not have a unit in the denominator. Okay? So you always start with the number that does not have a unit in the denominator. Okay? And so this one has a unit in the denominator. It's kilograms. This one doesn't. So since I have two of them, I'm going to start with the one that doesn't have a unit in the denominator. So I have a 145-pound patient. Now this says that it's 11.5 milligrams of the drug per every kilogram of the patient. So I have to be able to use this, and I can't use that right now because I have pounds. I don't have kilograms. So I have to convert these pounds to kilograms. So on your sheet, it says that there are 453.6 grams in a pound. So 1 pound is 453.6 grams. They still don't have kilograms though. So I didn't quite do it this way. I did it my own way. Probably should have followed the directions, but I want to show you how you can do this a different way than what they said. They made it very confusing. So now I'm going to convert this 1 times 10 to the third grams is 1 kilogram. That's from the metric system conversions. It's from this chart right here. 1 kilogram is 1 times 10 to the third grams. Now I can say, okay, 11.5 milligrams per every single kilogram of the patient. And they want the dose in grams. So there's 1,000 milligrams per every single gram. So milligrams cancels out, kilograms cancels out, grams cancels out, and pounds cancels out. So then in my calculator, I'm going to put 145 times 453.6 divided by 1e to the third times 11.5 divided by 1,000. So if it's in the top, I multiplied, and if it's in the bottom, I divided. And so I get 0.756. All right, here a car is driving at 65 kilometers per hour. So in 1 hour, it's going 65 kilometers. And I want to convert it to meters per second. So I'm going to convert the kilometers first. So 1 kilometer is 1 times 10 to the third meters. It's from right here. And then I want to go from hours to seconds. So 1 hour, and I put hours in the top, so it'd cancel out with hours here on the bottom. And that would be 60 minutes. And then 1 minute is 60 seconds. So then I'm going to take 65 times 1e to the third divided by 60 divided by 60. And I end up getting 18 meters per second because minutes canceled out with hour, canceled with hour. Kilometers canceled with kilometers. And I'm left with meters over seconds.